Okay, can you tell me the difference between transient and volatile variables in Java?
Yeah, sure. Both transient and volatiles are, we can say, modifiers in Java. So transient mostly we use for the context of serialization, and this volatile keyword we use in multi-threading environment. So whenever we mark any variable as transient, so so that specific field will not be serialized. So whenever we are trying to convert an object into a stream of bytes, so like serialization, so then the value of transient field will be ignored and that will not be included in the serialization from the object. Okay, but the volatile keyword is uh, like whenever we declare any um variable as volatile, so it tells JVM that the value of this variable may be changed by different threads. Okay, and simultaneously it would be getting updated. Okay, so it is kind of it ensures that whenever one thread updates the value of volatile variable, the new value should be immediately visible to all other threads. Okay, it should not be delayed. So yeah, so that is the use of uh, these two variables.
How about atomic keyword?
Yeah, atomic uh, variable in Java, we primarily referring to variable that can be read and updated in a single operation. So that means that the operation is thread safe without needing external synchronization mechanism like use of any synchronized blocks or any kind of lock mechanism. Okay, so when an atomic keyword we use, so that means that the operation will either completely fully happen or will not happen at all. Okay, so there is no kind of middle ground we can say, and the operation cannot be interrupted while the it is being performed. So in Java we have atomic integer, atomic long, boolean, and all. So these basically offer atomic operations for primitive types. So yeah, that's what I know about it.
Mm-hmm. Okay. Okay, so what is the difference between hash map and concurrent hash map?
Yeah, concurrent hash map is used in multi-threaded environment, and hash map is not thread safe. So in hash map, if multiple threads try to read or modify a hash map simultaneously, so that can lead to data inconsistency and all. Okay, but in case of concurrent hash map, so that actually what happens in this case, it uses the approach of segmentation. So instead of locking the entire map when one thread updates a value, it divides the map into smaller segments. Okay, so each will have its own lock. So multiple threads can access different segments of the map simultaneously. Okay, so at a time only that uh, a specific segment will be locked wherever the any write operation is happening, and uh, others will be free for the other threads to read it. So concurrent hash map ensures thread safety for individual operations like put, get, or remove operations. So yeah, so the main difference is so hash map is not thread safe, whereas the concurrent hash map is thread safe. And also one more difference is that a hash map allows null keys and values, but concurrent hash map does not allow null for either keys or the values. So yeah, this is the difference between these two.
Okay, so how you can achieve synchronization in HashMap?
Yeah, for that we can use we have collections. So collections class provide synchronized map. So we can use collections dot synchronized map for that. So this way we can get a synchronized version of the hash map. And another way is we can use synchronized keyword around the section which we want accessing or modifying the hash map. So whenever we have suppose hash map, so we can say like public synchronized void or put, okay, and then inside that we can just add map.put method we can do. And similarly while get also we can do that, maybe synchronize the string get, and there we can return the map.get of that key. So that is also another way we can achieve that.
Okay, okay, okay. Okay, so what is class loader? You know?
Yeah, class loader is a part of JRE, and that is responsible for loading classes into memory whenever we run a Java program. The JVM needs to load classes before they can be executed, and their class loader comes into picture.
Okay, so do you know what are the types of class loaders in Java?
Yeah, so we have Bootstrap, and then system class loader, extension class loader. So in Bootstrap, that uses the rt.jar. Okay, so uh, this jar contains like we have multiple utilities like classes like java.lang, util, and all that, string, object, all that are the part of this rt.jar. And then for extension class loader, like it loads the responsible classes from the live external directory of the jars, like java x.star and all. So those things will be loaded from here. And then in system class loader, it will load all the classes from the class path. So yeah, so these are the three types of loaders we have.
Okay, can you explain the difference between overloading and overriding?
Yeah, overloading is basically whenever we define multiple methods with the same name but different parameters. So different parameters means either in the number or type of parameters. So anything is there. So overloading allows a class to have more than one method that performs similar but slightly different task based on the parameters passed to it. So this is what is overloading, and this is also called compile time polymorphism. So it happens basically at the compile time. And method overriding happens between the superclass and subclass. So whenever a subclass provides a specific implementation for a method that is already defined in the superclass, so the method in the subclass has the same name, return type, and parameters in this case. So as the method in the subclass. Okay, so overriding is used to provide a specific behavior in a subclass while maintaining a method signature from the superclass. Okay, so it will always have the same method signature, whatever it has in the superclass, and basically it is used like as I told in case of inheritance, and this is also called like runtime polymorphism because which method will be loaded, so that is decided at the runtime. So yeah, so this is what is the difference between these two.
Okay, suppose you have a scenario like you have a superclass with an overloaded method, okay, and also you have the subclass which overrides the same method, okay. So you have a superclass with the overloaded methods, and you also have the subclass which overrides that method, okay. Now suppose you create an instance of the subclass and call the overloaded method. So how it will behave? Can you explain?
Yeah, so we have a superclass with an overloaded method. Okay, so let's say we have a superclass, and if it has two methods, like let's say some display method is there, okay, and input parameter, let's assume for one it is accepting int, and for another one it is accepting string. Okay, so after that you were saying that we also have the subclass, so that overrides it. So let's say we have some subclass that extends superclass, and that is overriding this display. And this time, let's say this display does not accept any parameter, so this will be overridden. Okay, so now if we create the instance of the subclass, so if we say, so now we have the superclass with uh, uh, I mean superclass display method with integer and string, and we have subclass with just I mean without any parameter. So if we are calling uh, I mean that subclass object of, and then just dot display, so it will call subclass because that has been overridden already. So it will call the subclass. But if we are let's say we are passing 10, okay, the display in that we are passing some integer 10, so in that case I mean it will call the superclass. So yeah, so it depends. So the one which has been overridden, so that overridden one will be the called, but the rest, for the rest of them, the superclass will be called. So it depends on the signature.
Okay, okay. Good. Okay, so how exception handling happens in Java? Can you explain?
Yeah, exception handling. So we have the uh, we have the throwable class on the top, and then we have exception, and then and error. Okay, and then in exception we have checked and unchecked exception. So this is what is the complete hierarchy. So coming to exception, so exception is an event, we can say, that disrupts the normal flow of the program's execution. So uh, in Java exception is in Java exception is represented by the throwable class, so which has two main subclasses, as I told, like error and exception. So again, this exception has like checked exception and unchecked exception. Okay, so checked exceptions like we have IO exception, SQL exception, and all. Okay, so these exceptions that compiler forces us to handle. Okay, so if we do not handle it. So, I mean, if we are using suppose any ID and all, so in that case we can see that the compiler is showing that kind of error at that point of time. This is what is the checked exception, and unchecked exception is the that it happens at the runtime. Okay, and checked exception basically it happens at the compile time. So runtime, so the checked unchecked exception, we have like null pointer exception, array out of bound exception. So all that comes under the unchecked exception. Okay, so we are required to handle these exceptions explicitly, but this basically happens because of I mean the programmer is not handling it carefully. So we need to I mean analyze like wherever we need to handle this, and based on that we have to handle that. Okay, then we have error. So error is also like out of memory error, stack overflow error is there. So uh, uh, that is like something which we cannot handle. Okay, so I mean suppose if system itself has out of memory, and whatever the assigned memory is there with the Java that is exceeded, so at that point of time we can see that. So that is not in our control. So yeah, so we can use basically try, catch, and finally blocks for handling of the exception. So yeah, so this is what is the exception.
Okay, okay. Okay, so what is lambda expression? You know?
Yeah, lambda expression, it helps us to simplify code, especially when we are working with functional interfaces. Uh, Using lambda expression, we can write the more concise and compact code. Lambda expressions are very much useful with Java Stream API for working with collections in a functional style. So that enables the operations like filtering, mapping, and reducing the data in much efficient and cleaner way. So yeah, so that is what is the Lambda expression.
Okay. Okay, so what conditions are required to make sure that if it is a functional interface?
Yes, yeah, functional interface will have exactly one abstract method, and it can have multiple default or static methods. Then we use on top of that interface, we can use annotation at the end of functional interface. So that basically will make sure like we are following these conditions, like having only one abstract method and like any number of default or static methods. So yeah, so these are the conditions which are required.
Okay, so you know optional, right?
Yeah, I know it.
Okay, so what is it? Is it a class or interface?
Uh, Optional is a class. Yeah,
Okay, can you explain what is it?
yeah. Optional class was introduced in Java 8, and it is like a container object which may or may not contain a non-null value. So it was introduced to avoid the multiple null pointer exceptions and make the code more readable and maintainable when dealing with the nullable values. So it provides various methods like off, optional off, and empty, right? So off nullable. So yeah, so these are the various methods it has, and then each present is there. So all these we can use as per the requirement.
Okay, okay. Okay, suppose if you want to reduce the memory uses or memory leaks of the Java application, okay, so what strategy you will apply?
Yeah, so basically there can be multiple factors for it. So like so I mean, one way is like we suppose if we are using try with resource or something like that. So any file we are reading, okay. So we should always try to close the connection whenever our task is done. Okay, so we should explicitly nullify the any reference we are doing. Okay, and then we should check like any unclosed resources in the finally block we can add that, right? And we should also check any kind of circular references are there, right? If it is making any chain system or something like that, so those things we can check. And also we can use appropriate data structures. Suppose anywhere we have to like scenario where the array list or linked list is more suitable, so we can use that, right? And then we can also analyze the and optimize the memory uses. So we can use profilers like JVisual VM or JProfiler we can use to visualize any kind of memory leak or any issue is there. Okay, so we can analyze the heap dumps also to locate objects that consume a lots of memory. So we can look for unexpected or unnecessary objects that could indicate the memory leak. So these are the things are there which we should use.
Okay, do you know partition by or partitioning by keyword along with streams?
Yeah, I know that.
Okay, can you explain?
Yeah, the partitioning by method. So in that we divide the elements of a stream into two groups based on the predicate. So like it returns like a map of either true or false, like boolean will be there. Okay, so where the that key will be true or false only. Okay, so uh, the value is a list of elements that satisfy the respective condition. Okay, so I mean it will always have two items. So I mean based on the condition it will partition the whole element.
Okay, can you give one a small example of it?
Yeah, so the main example is like suppose we have a number 1 to 10 and we want to partition the odd and even numbers. So what we can do is like whatever numbers are there we can stream it, and then we have collectors dot partitioning by, right? So in that we can like just say n modulus of 2 equal to 0. So it will, the response will be like map of boolean and list of integers. So whenever we say suppose the output we are storing into the object called partitioned. So whenever we say partition dot get true, so it will give us the, I mean, uh, even all the even numbers, and if we say partition dot get false, it will give us the odd numbers. So yeah, so this is one of the use case of it.
Okay, okay. Okay, so what is the difference between interface and abstract class?
Yeah, interface is a reference type similar to a class, and that can contain only constants, methods, signatures, default methods, and static methods and nested types. So interface cannot contain instance fields or constructors. So since Java 8 interface can have default and static methods also. So a class implements an interface by providing the behavior of the method defined in the interface. So the abstract class, we can say it has both abstract methods, like without a body. Okay, so it has only the method name without its implementation, and concrete methods, so method without its body. Okay, so abstract class can contain instance variables and constructors, and they can be extended by other classes. So unlike interfaces, a class can extend only one abstract class but can implement multiple interfaces. Okay, so yeah, so that's the difference between these two.
Okay, and what is the difference between double equal to and equals method?
Yeah, the double equal to operator compares the memory address basically of the object, and not the actual contents. So the equals method, which is defined in the object class and can be overridden by other classes. So that is meant to compare the content of the objects basically. So rather than the memory references. So for example, suppose two different string objects containing the same sequence of characters with the, I mean that will be considered equal when using the equals method, but whenever we are using double equal to, then we cannot say that it is equal. So yeah, so that's the difference between these two.
Okay, so what is the difference between final, finally, and finalize?
Yeah, final keyword can be applied to variables, methods, and classes. So when we apply to a variable, so it makes a variable like constant, and whenever it is applied to the method, so it prevents the method from being overridden in subclasses, and when it is applied to class, so it prevents class from being subclassed. Okay, and then finally block is used in exception handling basically. So it is a block of code that will always execute regardless of whether exception was thrown or not. So only when it will not work, when we just say system.exit or the system crashes, so at that time only it will not run. Okay, and then finalize method is defined in the object class and is called by the garbage collector before object is destroyed, and it is rarely used in Java, as it is a way of performing cleanup, but Java's garbage collector usually handles a resource deallocation automatically, so normally we don't call this. So yeah, so this is the difference between all this.
Okay, okay. So what is singleton class in Java and how you can create that?
Yeah, singleton class in Java is designed to have only one instance throughout the um, application's lifetime. So that ensures that there is only one single instance of the class. So that can be accessed globally basically. So the singleton pattern is implemented by making the constructor of the class as private. So first of all, we can make it private, and then we can have a like a double check locking. Okay, so there uh, we can just check it two times, like if any instance is equal to null, then normally we allow that to the next synchronized block. Okay, and again after the synchronized block, again we can check if instance equal to null. So that way we do the this checking two times, and if still it is null, then we assign the, I mean, new, I mean, object of that class to the, I mean, instance of that singleton class. So yeah, so that is what is a singleton class.
So what is tree map? You know tree map?
Yeah, so tree map is is a part of I mean map only, but that implements the sorted map interface. So it stores elements in key value pairs, but that guarantees the keys are sorted in ascending order. So that is the natural sorting order. uh, okay, and based on the red black tree, so operations such as lookup, insertion, and deletion are performed in uh, this tree map. So yeah.
Okay, so how do you create the Spring Boot project? What are the ways you are aware of?
Yeah, we can do it. I mean, various ways. So I mean, the most easier way is like using Spring Boot initializer. So we can go to springboot.io website, and there we can create the project easily. So we can choose there whatever the project type is, Maven, Gradle, or whatever it may be, and that language and the artifact and everything. So all those things can be given over there, and it will generate the project for us. And then the another way is like if we are using STS or IntelliJ, so through that also we can create the project. So we can just say new, then spring starter project, and we can do that. Also, apart from that, we can do using command line CLI. So that is also one way. So yeah, so these are the ways I am aware of.
Okay, okay, okay. Okay, so what is the use of at the rate of Spring Boot application annotation?
Yeah, so this at the rate of Spring Boot application annotation is a that is the annotation which has multiple underlying various annotations. So that is like at the rate of enable auto configuration, and at the rate of component scan, and at the rate of configuration. So these are the underlying annotations of that.
Okay, can you explain each of them?
Yeah, so enable auto configuration that tells Spring Boot to automatically configure the application based on the dependencies in the class path. Okay, so that is at the rate of enable auto configuration, and then at the rate of component scan tells Spring to scan the current package and its sub packages for Spring components such as anywhere at the rate of bean is there, at the rate of component service or repository, at the rate of controller is there. So all that will be scanned, and the bean of that will be created in the container. So so by default component scan looks in the same package and the class annotation with the Spring Boot application. However, we can also give the different, suppose any different packages there, so that also we can give separately. And then add rate of configuration annotation indicates that the class contains Spring Bean definitions. So it's a marker that indicates the class can be used by Spring IOC container as a source of the bean definition. So yeah, so this is what is the this annotation, Spring Boot application annotation is.
What is the difference between Spring and Spring Boot in very brief?
Yeah, Spring is a framework that provides various modules like Spring Core, Spring AOP, Spring Data, and all to develop Java-based applications. So Spring requires a lot of manual configuration. So those things can be overcome in a Spring Boot application. So in Spring Boot, that is a project. So that is built on the top of the Spring framework only. So it simplifies the setup and configuration of the Spring application. So it provides defaults for application setup, automatic configuration, and embedded servers like we have Tomcat and all, right? So all these are embedded here, and that basically ultimately eliminates the need of adding the server separately. So yeah, so these are the benefits are there over Spring for Spring Boot.
So what is a Spring Boot starter?
Yeah, Spring Boot starter are predefined sets of dependencies, we can say. So that is used to easily integrate common features into Spring Boot application. So we have a Spring Boot starter web, right? So whenever we have to build web applications, so for RESTful APIs, so we can use that. And then Spring Boot starter JPA is there. Okay. So like for that also using data JPA, we can work with the databases and all. So yeah, so yeah, these are the few of the Spring Boot starters.
So what is a Spring Boot actuator?
Yeah, Spring Boot Actuator basically provides the production-ready features like monitoring and management of a Spring Boot application. So we have health metrics, environment, and many other endpoints are there. So using that, like we can check the health of the system, we can get the like performance metrics or the environment properties and all. So those things we can, get using this Spring Boot actuator. Yeah.
Okay, okay. So what is the difference between REST controller and controller?
Yeah, so these are the notations, which is commonly used in Spring Boot or Spring project. So add controller is a standard annotation that is used for Spring MVC. Whenever we have the requirement, like we have the views with GSP or some similar technologies, so we use model view, and there we pass it. But at REST controller, that is a specialized version of controller, we can say. So it was introduced in Spring 4. So it is used when building RESTful web services. So it is convenience annotations that combines like add rate of controller and add a response body. So we don't have to write add the response body explicitly here. So any method inside add the data rest controller is assumed to return JSON or XML response automatically without needing a data response body on each method. Okay. So I mean it automatically adds the response body. So yeah, this is the difference between add the rate of rest controller and add the rate of controller.
What are the advantages you see of using microservices?
Yeah, there are various advantages like microservices, we can say, are like kind of scalable. So each microservice can be scaled independently based on the its resource demand. So suppose I mean we have lots of traffics are coming up for some specific kind of module of the microservice. So we can just increase the load on that microservice, or we can create the multiple instances of that. So those kind of flexibility we have. Okay. And then also we have the flexibility in the technologies. So like one of the microservice can be written in Java, another microservice can be in .NET or some other programming language. Okay. And then uh, microservices are allowed to development teams to work different services simultaneously. So we have many team members, right, working together. So like same person does not have to work on the like all the microservices, right? So it can be easily distributed among the all the developers, and they can work that, and it can be developed faster. So and also the its maintenance and deployment is easy. So microservices can be updated, deployed, and maintained independently without affecting the other services. So yeah, so these are the advantages of microservices.
Okay, okay. So do you know API gateway?
Yeah, API gateway, we can say that acts as a single entry point for all client requests and routes them to the appropriate microservices. So all the requests which are coming up, so they don't need to know like which microservices it is supposed to be called. So those things are taken care by the API gateway. Okay, so it has various functionalities like it requests routing. So the routes request to the appropriate backend microservices, and load balancing also can be done here. And then authentication and authorization is also done in the API gateway. Like we can write the permissions and all also for the each user, and who can access what. So all those things can be managed here. Okay, and then rate limiting also can be done. Okay, so it can limit the number of requests from the client to avoid any kind of overloading issue or any kind of crash. Okay, and then also response aggregation, so it can aggregate responses from the multiple microservices into a single response to a client. Okay, so suppose any request is coming, that that request need to be sent to the multiple microservices, and then the combined result of those microservices are supposed to be returned. So in that case, that also can be done here. So yeah, so these are the things which can be done as part of API gateway.
Okay, okay. So which API gateway you have worked on?
Yeah, I have worked on Spring Cloud Gateway.
Okay. So what is circuit breaker in microservices?
Yeah, circuit breaker is a design pattern used to handle failures in microservices. So it basically prevents a service from repeatedly trying to perform an operation, and that most likely that can fail. Okay, so that could lead to some cascading failures, right? So in those kind of situation, we use circuit breaker. So the circuit breaker is opened when failure reaches a certain threshold. So for that we use open state. Okay. So it prevents a further call to the failing services. Okay. Then we have closed state. So circuit breaker is closed when everything is functioning properly, allowing normal operation. Okay. So that will be the normal operation. Then half open state, after a certain time, the circuit breaker enters the half open state to test if the service has recovered. Okay, so if the call succeeded, then the circuit breaker closes again. So yeah, so that is what is the circuit breaker. And yeah,
Okay, so which one you have used for this?
yeah, I have used libraries like Hystrix.
Okay, okay.